Preliminary Literature Review Number 2. For my second literature resource, I chose to review the examination of the relationship between 8th grade students' learning styles and the attitudes towards mathematics, written by Benjamin Adin. In this article, Adin delved into determining whether the attitudes towards math class and their learning styles had a correlation between grade 8 classrooms. I found this interesting considering the great amount of work that we had done on growth mindset and math class this year, specifically in modules. There is a common conception that there is such thing as a math person, and the statement students may say is, "I am not a math person." A quote from this article, which I feel is applicable to this, is, "Math class is seen as hard and boring by students, and a lesson which is hard to teach, to which students' interest is low." My goal is to break the stereotype. I want to show students that everyone can be a math person, as it is everywhere in our everyday lives. Through my lessons, students will learn how math is useful outside the classroom. Math may be made easier to understand if students delve into the information in which all learners are met and reaching all learning styles. This promotes a positive growth mindset. This article supports my theory that attitudes towards math is crucial when it comes to teaching math. In this way, we as educators must first start by making sure that students of all learning styles are engaged. We must make math interesting and applicable to the lives of our students. They must see the use of the knowledge being taught. I've heard so many times in my classroom, "When will I ever use this?" It is my goal to make sure that the students see where they can use this in real life. Preliminary Literature Review 3. My third and fourth literature resources I found during my second round of research. I don't know why it didn't occur to me before, but a major area of interest related to equity in the math classroom would be math and gender. In the collection of scholarly articles called Towards Gender Equity in Mathematics Education, an ICMI study, edited by Jill Hanna, 2 articles stood out to me. I looked into the background of Jill Hanna, and she's a professor at OASI, whose research topics include mathematics education, the role and proof of mathematics education, philosophy aspects of proof, and the gender mathematics education. In my third literature resource, the article Mathematics, Gender, and Research by Elizabeth Fenma, she notes that there is an achievement difference between the genders. What I found most interesting from her research is that the students' achievement levels differ the most in middle school and secondary school, which later translates to, and this is a quote from the article, major differences in participation in mathematics-related careers. Many women capable of learning the mathematics required choose to limit their options by not studying mathematics. This has correlations to one of the modules which we completed in Brock in math this year. The module is on the stereotypes of the female gender in math. In this module, videos showed depiction clips from movies and television where women purposefully acted less intelligent to seem attractive. This way, they could look helpless, waiting for men to help them solve their problem. An example of this would be Cady Heron from Mean Girls. She was brilliant at math, and she was actually part of the mathletes, but to look attractive to a boy that she liked, she started to fail in math. I shared this response in my blog post for the math module that week. Preliminary Literature Review Number 4. In my fourth literature resource, Gender and the Mathematical Mythology and Misogyny by Mary Gray, she makes a statement that, for women, the major barrier to achievement in mathematics and related fields is the mythology surrounding their aptitudes and abilities. This is on page 2 of the article. Both of these articles open my eyes to a new obstacle. When it comes to the question of how can I create an equitable math class, I need to focus on ensuring that both my male and female students feel comfortable showing their ability in math. I do not think that it is all society that is perpetuating this stereotype, the stereotype that is setting women back in their ability to feel comfortable learning and presenting their math skills. Nevertheless, I believe that this stereotype has been instilled by part of our society, such as media, putting more focus on women's worth and their looks rather than their brains. I do not want my female students to be in a world where they feel like they are being held back by the glass ceiling which Gray states that the mathematics field imposes on their gender. Preliminary Literature Review number 5. For my 5th literature resource, I chose to focus on the area of equity, reaching all learners within the classroom by teaching the students math where they can see the practical use outside the classroom, real-life math with enduring understandings. I wanted to find this article written by Jo Baylor, as she is a researcher we learned much from in our online modules this year in Mathematics 2 at Brock. Jo Baylor focuses a lot on math and growth mindset. I found the article, Open and Closed Mathematics, Students' Experiences and Understandings, written by Jo Baylor for King's College London University. The first line reads, "There is a growing concern among mathematic educators that many students are able to learn mathematics for 11 years or more, but then are completely unable to use this mathematics in situations outside the classroom context." In this article, they completed various research projects wherein adults and students completed tasks which required math learned in the school in real-life situations such as shopping. They found that the test subjects did not use math they learned in school to solve these problems. They also did not recognize the correlation between the two situations. What I found most interesting is that their choice of mathematical procedure depended more on their environment or the context than the actual mathematics within the task. Lav called this type of learning situated learning. This definition is in my definition in terms slide previously before the slide. This is why this experiential real-life problem-solving inquiry math should be used within the classroom. This disconnect between classroom math and real-life math reflects back to the statement I stated before. When will I ever use this? I hear this statement every once in a while in my classroom, and I specifically go out of my way to show that student how would you really use this in real life. For example, in my first placement, one of my students asked me, when would we ever bisect an angle in real life? I then showed them a YouTube video where a carpenter had to bisect an angle to measure molding for a house. Again, in my last placement, a student asked me, when would we ever use coordinates and the Cartesian plane? I then showed them with the application of using battleship and longitude and latitude how you would use the Cartesian plane in real life when using coordinates on a map, or if you're using for travel or the military. My action research plan. Data sources. Data sources. What are your data sources and why did you select these to collect? I chose anecdotal notes, interviews, and students' work or tests to create a variety of qualitative and quantitative data sources. For anecdotal notes, I chose this because they are quick observational notes that can be done in the moment and put in an Excel spreadsheet so that you can quickly review them to assess for growth later. They are short, to the point, condensed, and focus on key observations. For interviews, I chose this because it gave inner thoughts, looking for fixed and growth mindset as well as attitudes towards math and learning equity through math. Similar to novel studies conferences, this also checks for understanding. This allows for students to explain, clarify, and expand on their thinking orally. If it is difficult for the students to write or show a mathematical process, this can help them show their work orally in an interview. With students' work and tests, I can see a hard proof with numbers and facts to show baseline knowledge before the unit diagnostic, mid-unit ongoing learning, seeing if the action plan is actually making progress, and the end product to see if the action research plan was effective. This shows different stages of the unit, and it can also show if it's being effective throughout. This way I can give descriptive feedback to help students in need. Instruments and scales. For this action research project, I would use a variety of instruments and scales so to have a difference of qualitative and quantitative data. For anecdotal notes, I would use a class list and record anecdotal notes next to each student's name. I can then put that into an Excel spreadsheet later so that I can access it through Google Drive. With Google Drive, I can access this at any time, anywhere. I'd be looking at 5 students per day so that I could see the entire class within a week, based on a 25 student class. For interviews, I'd use audio recordings, notes in an interview log with dates, times, and students interviewed. I would use a chart to organize these log entries, and then I would later be able to put this into an Excel spreadsheet. Again, I would upload this to Google Drive. For students' work and tests, I would have a class list with corresponding marks and progress notes with constructive feedback. The hard copy I'd keep in a class binder, and the electronic copy I'd keep in an Excel spreadsheet on Google Drive again. Google Drive is an extremely useful resource as you can access this at any point of time and anywhere. I could even access it on my phone or at home when marking and looking at progress. Triangulation, validity, and reliability. For what, how, and why, for anecdotal notes, I would have during the work period for how. What, I would have dot notes showing keynotes, condensed information, which you can easily refer to in your Excel spreadsheet for looking for growth and change. And why is because it's qualitative in the moment and takes less time. For interviews, I pull a select few students during the work period. For what, I would be looking for their main thoughts and feelings on growth mindset and fixed mindset and attitudes towards math. And why, I would have qualitative. I would choose interviews because it gives more insight. This also allows students to casually talk about their feelings in math. For triangulation, validity, and reliability of my last resource, students' work and tests, I would collect these throughout the unit, during the beginning, during the middle, and during the end of the unit to see the different progress. The beginning of the unit would see the diagnostic results. During the work periods and during the work time, it would give constructive feedback and see the ongoing progress. The final test would be the end product to see if the action research was effective. For what? This would give a baseline knowledge of before for the diagnostic, the mid-unit to seeing if the action research is making progress, and the end to see if it was effective. And why is because it's quantitative. It gives hard proof with numbers and statistics if the action research was effective. So between all 3 of these different sources, the triangulation, validity, and reliability of this information should be covered, giving different sources of quantitative and qualitative data to support each other. Participation and setting. Who are the participants in the study? For anecdotal notes, I would take anecdotal notes on all students throughout the units. If possible, take anecdotal notes on all students during the work period. But if not possible, take at least 5 students to take anecdotal notes on per work period so that by the end of the week, you would have a log of 25 students, meaning it would be the whole class if it's a 25 student class. In this situation, for interviews, I would interview all the students at the beginning, middle, and end of the unit if possible, even if it's just to meet with 3 to 5 students each class. If it proves to be too time-consuming and you are constrained by time constraints, then I would choose a select few, but I would be careful about census versus sample issue. So make sure that you sample a student from each level of learners to get a good sample. For students' work and tests, I would review all students' work and test, as you must grade them anyways, and look at each of their works, creating small descriptive feedback and notes on their progress throughout each.